Okay, so we're going to do a couple more word problems, but before we do, I just want to give you a hint. The last three were all consecutive, even or consecutive integers or consecutive odd integers, so it was really clear what the variables should be because we've already talked about that. But if you have two values that you're trying to find, like sometimes length and width, or sometimes you're looking for two different numbers and it's hard to tell which one you should find, and it may be unclear for you to know which unknown you should make your variable be equal to. Then what I want you to do in that case is find the comparative statement. What's where a statement is comparing one of your variables to the other. Then what I want you to do is to let your variable be equal to the unknown that the statement is being compared to. It's often written as the second variable mentioned in the sentence. For example, if I have this problem, the area of a rectangle is 28 square feet. The length is 1 foot less than twice the width. What are the dimensions of the rectangle? We have three sentences. The first sentence talks about area and gives you some information. That is not comparing one variable to another. The second sentence says the length is blah 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 to the width. The length is being compared to the width. I know there's a lot of words in there, but I am comparing the length to the width. Do you see how this is the comparative statement? Okay. So it says let your variable be equal to the unknown in the statement that's being compared to. The length is blah 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 to the width. Okay, the length is 1 foot less than twice the width. It doesn't really matter what all that junk is. If I'm just trying to figure out what the variable is, I am going to let x be equal to the width. It's the one that mentions second in the sentence, and it's the one that length is being compared to. So I'm going to let x equal my width. This is the easiest way to do it. Technically, you could do it let x equal the length, but it's so difficult to find out what the width is in terms of length if the length is being compared to the width in this case. So if you let x be equal the second thing mentioned, or the thing that's being compared to, then when I go back and try to figure out what the length is, it says the length is 1 foot less than, that word than, remember what that word than says? The -1 goes in the back, twice the width, 2x less 1. Okay, now we're not going to actually finish this problem until later. I was just trying to get you to understand that the length is 1 foot less than twice the width is the comparative statement, which is going to help you figure out what the x is. So let's practice this on the next problem. One number is 3 less than twice another number. The product of the two numbers is 20. What are the numbers? Okay, so notice I'm looking for two things. Numbers. Okay, so because there's two things, I don't know which one I should make x be equal to. So what I'm going to now look for is the comparative statement right here. Clearly the first sentence is saying that one number is being compared to another number. Well, which one should be our x? Well, x is going to be the another number. It's the one mentioned second. So this is going to be our x. So we're going to let x be equal to this first number, okay? So now that I have that comparative statement and I know x is this guy, I need to write the other one. So the other number, or one number, is, I already have that second number, is, okay, 3 less than, what does than mean? Than means I'm going to switch my order and the -3 is actually go in the back. 3 less than twice another number. So twice the x, twice this x, 2 times this x, less 3 is the second number. Okay, that was step 1. Step 2 says if you have a picture, you can draw it. Still no picture. Step 3 says write the equation. Well, we've already basically used up everything from that first sentence. So I'm going to keep reading from the second sentence on and see if I can't write an equation. The product, okay, stop. As soon as you get to the product, we stop and write a multiply. And then we have to go back to read because I have to figure out what the heck I'm multiplying. And what is it that I'm multiplying? Well, the two numbers. What two numbers are we talking about? Well, the two numbers are the numbers that we talked about in the previous sentence. So you have to look at this all as one little paragraph. The product of the two numbers By the way, the two numbers were the things that I just mentioned in the last sentence, which I've already decided are x and 2x minus 3. These are my numbers. Is. What does is mean? Is means equals 20. And now I have my equation. Step 4 says to solve that, and you guys know how to solve this now. We have 2x squared minus 3x equals 20. Subtract 20 from both sides to get 2x squared minus 3x minus 20 equals 0. I'm going to try to factor it, because if I can factor it, I prefer to do that. 4 times 5. Let's say 1x and 2x. I don't want the 2 and the 4 next to each other, so I'm going to put the 4 up here. That gets me 8 and 5, and on my first try I can use two different signs, that's what this says, two different signs, and add to a negative. So I put the negative on the bigger number, the bigger product, and that slips in. Make sure you're putting the negative on the bigger product out here, the 8 and the 5, not comparing the 4 and the 5, but 8 and the 5. So I'm going to get x minus 4 times 2x plus 5. Set each of those factors equal to 0. So I have x is equal to positive 4. And then negative 5 halves. So I have two numbers here. But are these the two numbers that my question is asking for? Well, still not quite. What did I solve for here? I solved for x. And what is x? X is merely the first number. So I also then need to find its corresponding second number. Same thing over here. If I found the first number here, I need to find his corresponding second number. Because I'm solving for x, I need to figure out what the second number is. So the second number is defined as 2x minus 3. But I know what my x is, don't I? I'm going to stick in 4. So 2 times 4 is 8, and 8 minus 3, my second number should be 5. So 4 and its corresponding second number, 5, should possibly be an answer. Let's see, negative 5 halves. So my second number will be 2 times x minus 3, but my new x is negative 5 halves. Well, this isn't too bad because the two 2's divide out, and I'm getting negative 5 minus 3, or negative 8 as my second number. So the other two pairs of numbers are 5 halves and negative 8. So these are my two possible sets of numbers. Step 5 says to check. I'll do that check over here. Okay, so our 4 and 5 work. Let's check 4 and 5 first. Is one number 3 less than twice the other? So if I take 4 times 2, twice that number 8, less 3, is that 5? Yep, that first sentence works. Is the product of my two numbers equal to 20? Yep, that works. So 4 and 5 seem to work. Let's now check negative 5 halves and negative 8. Alright, if I take one of those numbers, negative 5 halves, and I'm doubling it or twicing it, less 3, that gets me negative 5 minus 3, or negative 8. Okay, that first sentence works. Is the product negative 5 halves times negative 8? 20, I don't know. Negative times a negative is a positive. 5 times 8 is 40. 40 over 2. That is 20. It works. So both of these answers do work. I was able to check. Notice I checked with my words and not with my equation. I actually find it easier to check with the words, and it's more thorough. Our next problem says 3 times the square of a number is 6 more than twice the number. What is that number? Okay, this one doesn't have two numbers, so I don't need to worry about the comparative statement. So I'm just going to say let x be that number, the unknown number, because there's no plural here. Okay, step 2 is a picture can be drawn here. Not so much. So step 3 says to write your equation. So I have to go back and read it one more time and make sure that I am writing the equation that they were giving me. 3 times. Okay, stop right there. 3 times. I can write 3 times. Let's keep reading then. The square of a number. Okay, the square of a number. Well, that's just x squared. Is means equals. 6 more than. Uh-oh. What does than tell you to do? Than tells you to take that 6 more and put it at the end. So I know I'm going to do something plus 6. Because the 6 and the twice the number have to switch places because that's what the than tells you to do. And then twice the number. Now, if you put 6 plus 2x, you would probably get away with it because addition is commutative, but subtraction is not. So if this said less and you didn't switch the order, then you would totally get the problem wrong. So we're going to practice every time it says more than or less than to switch the order because that's what than tells you to do. Then you won't make very many mistakes. Step 4 says to solve. So I'm going to move the 2x and the 6 over. You can use transposition or you could subtract, either way you like it. I don't know if it factors. Let's try it. 1 times 6 or 2 times 3. So I'll try 1x and 3x. I don't want to put the 3 and the 3 next to each other, so when I try 2 and 3, I'll be sure to put the 3 opposite of it. 9 and 2. That doesn't get me the right one. Switching them, that's not going to work because there's no GCF. So I'll try 1x and 3x and 6 and 1. 18 and 1. Nope, that's not going to work. What if I try 1 and 6? Nope, that's not going to work because there's a GCF there. Even if you tried it, it's still not going to get you the -2 that you need. It doesn't seem to factor here. We tried our best. It doesn't factor. We move on to the next method. So the next method that you were going to look for is a square root method. Well, it doesn't look like it's a square root method because there's a b term. Completing the square. Well, although you could complete the square, this a is not 1, and if I divide everything by 3, I'm going to get a fraction, and then that's definitely not, b wouldn't be even. This is not looking great for me. So what I'm going to try to do is I'm going to do this with the quadratic formula. A is 3, b is -2, and c is -6. And then I have x equals -b. b is already negative, so that's +2, plus or minus the square root. B squared is 4 minus 4 times a times c, all over 2 times a. So carefully work that inside of the radical, which gets me 4 times 3 is 12, and 12 times 6, 72. And a negative times a negative is a positive, so that's 4 plus 72. So I have 2 plus or minus the square root of 76 over 6. And 76, do you think that reduces? 2 times 38, 2 times 19. The 2's can come out, so we have 2 plus or minus 2 square roots of 19 over 6. And it looks like a 2 can factor out of the top, which means that the 2 and the 3 divide out. And I get x is equal to 1 plus or minus the square root of 19 over 3. Now, I was only looking for one number, correct? Because I was only looking for one number, I don't need to find its pair like consecutive even or 2 numbers. This is just the number. But in fact, there's 2 answers, isn't there? There's 1 plus root 19 over 3. Is that a number? Sure, and I'm assuming that when you plug it in, it'll work. And then I have -1 minus the square root of 19. So it looks like there's 2 possible numbers that when you take 3 times the square of that number, it's going to be equal to 6 more than twice the number. I'm going to leave you to go ahead and check that on your own. You don't necessarily need to check, but make sure that you answer with your units. And there's no units be shown here, so I think I am good.